Now, session 2, special cases of a direct plane similitude. First special case, if we have in the plane two fixed points A and A prime, two distinct fixed points A and A prime, and two variable points M and M prime. By this similitude, or by S, we have M, we have A gives A prime and M gives M prime. S similitude K alpha. If K equals 1, and alpha equals 0 mod 2 pi, the case when alpha is 1, we have A prime M prime equals AM, and the angle between AM vector, A prime M prime equals 0. We get the vectors AM and A prime M prime are equal. So this figure is a parallelogram. Then we have M prime equals A prime, vector M prime equals vector A prime. Since M prime is the image of M by this similitude, and the vector M prime equals A prime, then in this case, S is a translation by vector A prime, since we have M prime equals A prime. And we write it like this, T by vector A prime. In this case, T A prime doesn't have a double point. It is no center in this case, if A and A prime are distinct. Now, if S equals similitude omega K alpha with K1 and alpha not equal to 0, mod 2 pi, in the case when K is 1, that is omega M prime equals omega M, and omega M prime equal alpha with alpha different than 0. In this case, S is a rotation of center omega and angle alpha, and we write S equal rotation omega alpha. To write this rotation as a similitude, you can write it similitude omega 1 alpha. Now, if S equal similitude omega K alpha with K strictly positive and K different than 1, and alpha equals 0, in the special case when K different than 1 and alpha with K positive, and alpha equals 0, since alpha is 0, so we have here omega M prime, omega M equals 0. The angle omega M prime equals 0. That is, the points omega M and M prime are collinear in this case. In this case, S is a positive homothency, or a positive dilation of center omega ratio K, of center omega and ratio K. We write S equal homothency omega K, omega M prime equals K. And we have in this case, in this special case, we have the vectorial equation. And when we have a positive dilation, we can write omega M prime equals K omega M with K positive. To write also this homothency or dilation as a similitude, we can write it similitude omega K 0, the angle is 0. If S similitude omega K alpha with alpha equals pi, in this case, omega M prime equals pi, that is the vectors omega M and omega M prime are of opposite senses. Then S in this case is a negative dilation of center omega and ratio minus K. Okay, S is a negative dilation of center omega and ratio minus K. That is, S is the homothency omega minus K. Omega M prime equals minus K omega M. Also, we have this equation, this special case. To write it also as a similitude, we can write it omega minus K, since K is negative, and pi. To write the negative homothency or negative dilation as a similitude, we can write it similitude omega minus K pi. Now, applications. Determine the nature and the main elements. We mean here by main elements, center, ratio, and angle. The first case, Z prime equals 2iz plus 5. To determine the nature, it's required to write this 2i coefficient of z in exponential form. 2i is equal to 2ei pi to 2. T is a similitude since k equal, we have the general case here. We have the general case. K is a strictly positive number and alpha not equal to 0 and not equal to pi. We have the general case. So in this general case, T is a similitude of ratio 2 and angle alpha. T, since it is a similitude, it is not a translation. So we have a center. T is not a translation since its k different than 1. And its alpha is different than 2 and pi, 0 not 2 pi. So it is a similitude. Since it is a similitude, so it is not a translation. This is the existence of the center. So it has a center. Since T is not a translation, because we have this or this, so it has a double point or center. To find this center, we replace here. We have S of omega, T of omega, equal omega, T omega equal 2i z omega plus 5. We do the calculation to get z omega equals 1 plus 2i. In this case, we have omega m prime equals pi to 2, and the length of omega m prime equals omega m. Very important remark, the triangle here, omega m prime, triangle omega m prime in this order, is a direct right triangle. Since angle omega m prime is strictly positive, you can say the triangle omega m prime is direct right at W, or at omega. Or we can say m prime W also is direct, or m prime WM is also direct right at W. Second application, same as before, we write 1 plus I in exponential form. T is also a similitude in this case, since K is radical 2, it's different than 1, and alpha different than 0. So also we have the general case. In this case, T is a similitude. Since T is a similitude, so it's not a translation, it has a center. Similarly, you can find the center. Fx of the center, we get it minus 1 plus 2i, minus 1 plus 2i, omega m prime equals radical 2, okay. The triangle m prime, G in this case, is right isosceles at M. Since we have here pi to 2, pi to 4, sorry, and Gm prime equals radical 2 Gm. So this triangle is right isosceles at M. We can say Gm prime also is direct right isosceles at M. Third, Z prime equals Z plus 3 plus 2i. In this case, this is a special case. Since we have here 1, coefficient of Z is 1, its exponential form is 1 ei 0, the exponential form of 1. So we have K is 1 and alpha is 0. Then T is a translation by vector V. Since here we have Z prime minus Z. Z prime minus Z, it is the fx of m prime. Here we can see Z prime minus Z equal 3 plus 2i. So Z of m prime equals Z of a vector. Let us call it V. We get this translation by vector V of fx 3 plus 2i. M prime equals V, where V has an fx 3 plus 2i. Now, as a homework, solve applications 4, 5, 6, page 27. Thank you.